Hi, this is Dr. Kunka Bheemalingappa, Faculty of CSE. I heartily welcome you. In this video, I'm going to discuss about design of epsilon NFA for a given regular expression. First, what do you mean by this regular expression? The language of this finite automata is expressed using a expression called regular expression. In the regular expression, mainly you consist of the operations closure, union, concatenation. Let us take one example of this regular expression. Suppose you have a regular expression A star B or B A star. How do you construct the epsilon NFA for this regular expression? First, we start with basics. For A, you are going to design the NFA as follows. Just for A, this is how you can make your design. Your input symbol is A. In a similar fashion, for A star, you can design the transition diagram as follows. First, already you are known how to construct for A. So, this is for A you are known. Right now this is a start state and this is the final state. As it is going to be changed, I am not reflecting that. So, you have to introduce a new start state. This is a new start state and this is a new final state. This is a new final state. You are known this was a previous start state and this is the previous final state. And you have to give a transition on epsilon from previous final state to new final state on epsilon. And also from this is a new start state you are known and this is the previous start state. From new start state to previous or say old start state, you have to give a transition on, that is epsilon. And then you have to give a transition from this new start state to new final state on epsilon. And also you have to give a transition on epsilon from this previous or say old final state to previous or old start state, that is on epsilon. So, this is A star. I think you have understood. So, this is how you are going to design NFA for a regular expression. If this is with respect to the input symbol A I have seen, with respect to the closure we have seen. You know what do you mean by this? Okay, closure, that is star. Star means 0 or more times. So it can have the possible strings of this A star are what? Just epsilon. So if it is epsilon, this is the path it is going to take. This is the path it is going to take. If it is single A, it is going to take this path. Epsilon, concatenation A is A itself. Concatenation with epsilon is A itself. But if you go this way, you are going to get one more A. But as you have only one A, you can go this way. Epsilon, concatenation A is A. A concatenation epsilon is A itself. That is how this A is going to get accepted by this epsilon NFA. Right. Suppose if you have say 2 A's, then how it is going to be processed is as shown here. Epsilon, A, epsilon. So you got A. For one more A, you are going to make your traversal like this. If you have say more number of A's like this, it is going to get repeated. On entering last A, you come to this like this, and then you are going to this final state. In this way, all possible strings of this closure are going to get accepted. Next, coming to this, just now I have seen for A and A star. Now you are going to look at, that is union. So for example, suppose you have, say, A union B. It can be given, some people use this plus symbol, and others they use pipeline symbol. That whatever you want to use, right, you can use. It is up to you. Pipeline or vertical bar, we say. Yeah. So for if I take this expression, in this mainly you have what? That is union operation. So how you are going to design epsilon NFA for this expression, simple expression consisting of union operation is as follows. You know, right, what symbols are there? You have, that is A and B. First, you can construct for A and then B separately, and then you can go for design for that, what you say, union, right? So let me separate this part to avoid your confusion. Yeah, you already were known, how to construct for NFA, sorry, for A. For A is this, right? This is a start state. This is final state. Anyhow, it is going to get changed, right? I'm not going to write that, double circle. This is A, right? You know, this is start state and this is final state, right? In a similar fashion, for B, how you can write? This is start state. This is your final state. But anyhow, it is going to get changed when you add this union operation. It is going to get changed. So I'm not going to double circle this. So just for B, the structure looks like this. Just for A, the structure looks like this. Now you have the operation word, that is plus. Plus means right now these two are new start. These two are start states for A and B respectively, and these two are final states for A and B respectively. Now for union, what you are supposed to do is you have to introduce a new start state. This is a new start state, and this is a new final state. This is a new final state. And you are known, these were previous accept or final states. So from previous accept or final states, you have to give a transition on epsilon to this new accept or final state. And then you are known, this is a new start state. So from new start state, you have to give a transition on epsilon to this previous or say old start states. This is epsilon. So this is what this union. I think I understood. So the possible strings are what? A or B. So if it is A, it is going to take this path. If it is just A, it is going to take this is a start state. It may go like this. Epsilon, A, epsilon. So if you concatenate, right, all these things, you are going to get A itself. This is how A is going to get accepted. In a similar fashion, if you take B, for B, it is going to take this path. And if you concatenate all the symbols, that whatever you come across in this path, you are going to get, that is B itself. That is epsilon concatenation B is B itself. B concatenation epsilon is B itself. So in this way, this it is going to get accepted. So this is about union. Next we look at, that is concatenation. Concatenation. Suppose we have a regular expression, say that is AB, right? A is followed by B. So how do you design for this? You are known, right, how to design separately for A and B. This way you are going to design. So this is start state. This is your final state. This is for A. For B, usually used to write for B in this fashion. This is the final state, right? So when you club these two together, so the final state of A and the start state of B, they are going to get okay clubbed. You are going to get okay like this. So some people, they introduce concatenation right in between this, like this. That is epsilon transition, and this is your okay final state. So some people okay like this, they write. So you know, right, what is the string of this okay expression AB? That is AB only, you know. So it is going to get processed right in this way. This is a start state, A epsilon B. If you concatenate the symbols along this path, you are going to get, that is AB itself, right? A concatenation epsilon is A concatenation B is AB. So the order is very important, whether it is AB or BA. If it is BA, you make this as B and that as A. The order is very important. I think you understood. So instead of some other people, they used to write okay this way. So without this epsilon, they are going to combine, they are going to merge these two states into okay single state itself. So let me okay show that. But I'm going to follow this okay a second method. It is up to you, whatever you want to follow. So by doing so, we can have one less number of state okay compared to that okay previous one. So for A, sorry, this is for A is this. A is followed by this B, right? So these two are okay combined into single one. That is this. This is how we can design epsilon NFA for simple regular expressions. So now we can go for basic operations you have understood. Now we are going to design DFA for this little more okay complex expression, that is A star B or B A star. A star B or B A star. Better let me take okay new slide. Yeah. The expression is what? Sorry. A star B or B A star, right? B A star. B A star. Okay. You are known, right? What are the possible things of this language? So in the first part, you can treat this as, if you spread this into two sub-expressions, okay, before union, you can take it as regular expression 1. After union, that is okay, regular expression 2. Say R1 and R2. If I treat this as okay R1 and this as okay R2. So from R1 part, what are the possible things of the language? And this we can treat it as okay R2 part, regular expression 2. From R1 part, what are the possible things we can have? A star in the sense 0 or more times. If you take, 0 times in the sense epsilon, right? So that is, you are going to get just B itself. Otherwise, a single A followed by B, right? Otherwise, any number of A's followed by B. So in every case, this B is mandatory. In every case, this B is mandatory. What happened? This B is mandatory from the R1 part. Your string must okay end with, that is okay B. If I take this okay second part, that is R2, it has okay B A star. So from this part, if I take this star value as okay 0, that means no A, then just you are going to get that is okay B itself. That one I have already written here. Other possible things are B followed by one or more number of A's. That is a B followed by one number of A, or say B followed by any number of A's. So in this case, this B is okay mandatory. In this case, this B is mandatory, you are known, right? So these are the some possible things of this okay expression. Now we will try to design epsilon NFA for this regular expression. Already have shown for basic operations how to design this epsilon NFA, right? First, we start with that is R1, that is A star B. So in the A star B, first you take for what? A, right? In the A star B, at first you can take for A. So you are known, right, how to design epsilon NFA for A. This is how, right, you are going to just A means, right, make the design A. But what you have, it is not just A, it is A star, right? Therefore, right now, if you want to number this number, you can give state number 1 is start state. State number 2 is the final state, but I'm not making final state, as anyhow it is going to get changed, right? So I'm going to introduce a new start state, a new final state, and you are known, right, what you are supposed to do from the new start state to, you have to give a transition from this new start state to old start state on epsilon, and also from the old final state to new final state, you have to give a transition on epsilon, and then this is going to be our start state. You have to give transition on, direct transition on epsilon from start state to final state. This is your final state. But anyhow, it is going to get changed, right? You are known. So that is the reason I'm not putting this double circle, right? This is R1 part, that is A star B. In a similar fashion, you have to write for that is in the R1 part, there is something called that is a first A star part you have done, but you have been left with what, that is a B. So B can be written like this. So this is your final state. Final state. So R1 part is over for A star B. In a similar fashion, you have to design for R2 part, that is B A star. You are known, right, how to make a design for first you can design for A star, and then for that you can that can be concatenated with B, right, on the left side. That order is also very important. You are known this B is to the left of this A star. First I can design for A star. So this is A, right? A star means you have to take new more starts, and you have to make a connection from the previous one to this new ones with epsilon transitions, right? And direct transition from new one to new one itself, new start state to new final, and also from old final state to old start state, you have to give a transition on epsilon. This is A star part. But for this A star part, you have this B to the left. So this I can treat it as what? B. So this is your start state. Anyhow, it is going to get changed. Anyhow, it is going to get changed. Yeah. As of now, this is your start. Anyhow, it is going to get changed. So for R1 part, R2 part, you have made your design. What you have been left with, that is union operation. For union, what you can do? So you can introduce a new start state, a new final state, a new final state. So from you are known. Let me give the numbers. Let me this 3, 4. In this, let me take this as 5, 6, 7. Whatever the numbers you want to take, you can take. Let me take this as 8. Let me take this as 9. Right now, 3 and 9 are old start states. And let me take this as 10. Yeah. This 11th one is new start state. New start state. You are supposed to give a transition from new start state to this old start state on epsilon, right? And also from this new to, sorry, yeah, from this new to this old start state, that is this. Just a second. It is not erasing. Yeah. So that is what this. And these are old final states. Okay, 8 and 10 are old final states. So what you are supposed to do, from old final state to new final state, you have to give a transition on epsilon. And also from old final state to this new final state, you should give a transition on epsilon. So this is the epsilon in FA for this complex expression A star B or B A star. You are known, these are some possible things of this expression. So B, how it is going to get accepted B? So there are two ways. It may go like this. Let me use that like a pointer. Yeah. For B, right, it can go in this fashion. It is going to final state. You are known this, this is a final state. It is having okay double circle, right? Yeah. For B, it may go that way, or otherwise, you have that, you can get that B from R1 part or okay, R2 part, right? So from R1 part, it is going to get accepted like this, or say from R2 part, in the sense it is going to get accepted okay like this. Here I have to write this. That is epsilon transition. It is missing. So let me. Yeah, this is, you are known, this is epsilon. Yeah. So the B is going to get okay accepted in this fashion. If I take say AB, how it is going to get accepted? This is start state. So A, in the sense it is supposed to take okay this path only, AB, right? So let me show that so that you can better understand. Laser pointer. A, in the sense it is going to get processed right in this fashion. AB. I think you have understood. This is how this A bit is going to get accepted. For two number of A's, for example, this is the path it is. Carefully watch. I am showing here. And something here it is missing. Yeah. We forgot to put this. This is the pen, right? Yeah. Star in the sense, yeah. This one also you are getting. That is from start state to final state, and also old final state to start state. This one you are going to have, right? Yeah. Now everything perfect. Let me show you how this 2 A's followed by single B, it is going to be processed. Yeah, this way it is going to get processed. First A, and then for second A, it is going to go like this, and then this is the path, okay, that is following. I think I understood. This is how this A bit is going to get processed. So if I take say BA, this is the path you have to definitely follow, right? Because from start state, here you are coming across that B. Yeah, B, that is this. Single A, right? So A, and via epsilon transitions, it is going to reach this final state. So if you concatenate the symbols that you come across along this path, it is going to get generated, that is okay, B itself. If you have say B followed by two number of A's, so B till this point B, this is first A, second A, and then it is going like this. If it is having say more number of A's, on encountering this last A, it is going to take this path. I think you understood this. This is how it is going to get processed. So in this way, we can design epsilon in FA for a given regular expression. You can take one more exercise at last. Let me finish it in fastly. I think you understood. So the expression is A star or B star. I just slightly changed the okay symbols. So you are known, right? What are the possible things of this language? Single A or two or more number of A's. Otherwise, B or two or more number of B's. You can have purely A's or purely B's. That too, one or more. So, how do you design this? First, let me take this as okay R1 and let me take this as R2. Right? First, for R1 part we can design. First, A star part, let me do. For A star in the sense, first, for A star, first you are supposed to make a design for A, right? Yeah, that is this A. A star in the sense, new start state, new final state. From new to old with epsilon, and also old final state to new final state on epsilon, and also from old final state to old start state on epsilon, and also transition on epsilon from new start state to new final state. This is A star, right? This must be concatenated with A, right? So what I'm going to do, this is a new start state, and previously this was your okay old start state, right? Anyhow it is going to get changed, right? So that is the reason I have not mentioned. Now this is a new start state. From new start state to this old start state, you have to give a transition on that A. You are known this A is to the left of this A star part, right? So that is the reason I'm writing here. I think you have understood this. Yeah. So for A star part I have completed. In a similar fashion, you need to do it for, that is B star. So first here also you can do it for B star at first. So this is B star in the sense you have to introduce, this is a new start state. Anyhow it is going to get changed, right? So this is a previous start state. So you have to give a transition on epsilon from new to old start states, and also from old final state to new final state, and also a direct transition on epsilon from new start state to new final state, and also old final state to old start state. This is B star. Already have seen this. And this B is to the left of this B star. So this is how this I can make a connection on B. This is, yeah, start, and this is your final. Anyhow they are going to change. These two are final states and these are start states for this regular expression. Let me give some numbering to our, okay, so that with that number I can refer. So 1, 2 are old start states here. This 3 and 4 are, say, old final states. And what is the operation next you have to perform? That is union. For union, what you are supposed to do? You have to introduce a new start state, right? So new start state. And this now, being this is going to be a final, I'm going to put a double circle for this. I think you understood. So from new start state to old start state, and also, yeah, from this new to this old start state, you are going to introduce transition on epsilon, and also from old final states to new final states. 3 and 4 were old final states, you are known. And this, yeah, let me give the number for this as 5. Yeah, from old final states 3 and 4 to the new final state, that is 5, you have to give a transition on epsilon. Yeah. So how this A is going to get processed, for example, single A. This is the path it is going to take. This is a start state, this path. single A. I think I understood. Let me use this laser pointer so that you can better understand this. Single A in the sense, it goes okay like this. 2 A's in the sense, up to this single A is over. If you go like this, you are going to get, let me repeat, yeah. Till this point you got a single A. If you go straight like this, you are going to get second A, right? That is AA. If you have say 3 A's, first A, second A, third A, and then it is going to take this path. So this is how it is going to accept the strings consisting of one or more number of A's. In a similar fashion, the explanation follows for the others. That is, one or more, the string consisting of one or more B's. Thank you for watching my video. Wish you a good day.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.